Welcome to another episode of Terry's Notes, and today I am going to be looking at the determinant of a matrix and the inverse of a matrix. Right now, let's look at a matrix. Let's call it M, and let's say the matrix is 3, 2, 1, 2, right? And I come and I ask you to find the determinant of the matrix. So I come and I say find the determinant of E. Sorry, not E, it's M. Right, so we want to find the determinant of the matrix M. Now, how do we write determinant? Now, determinant M is written like this. Okay, it's an M with two vertical lines on either side of the M. Now, to find the determinant, we take this term and we multiply it by this term. So it's 3 multiplied by 2, and then we're going to subtract this term by this term. So we're going to do 2 by 1. And I'm going to get 6 minus 2, which will give me 4. Okay, so that is how we find determinant. So as a general rule, if we have a matrix A and it's in the form A, B, C, D, the determinant E is given by A, D minus B, C. Now you notice how I put this in brackets and I put this in brackets. I advise you to do it that way so that you don't make a mistake, because when we have a matrix that has negative signs in them, you could easily get confused. So let me give you an example like that. So let's say we have a matrix A and it is given by 2 minus 1, 4 minus 2. Right? And I ask you to find, remember what this means? This is determinant. So the determinant of A is given by AD minus BC, which is going to take this and multiply by this first. So it's 2 multiplied by minus 2, put it in brackets please, minus, and I'm going to take this and multiply by this. So it's minus 1 multiplied by 4. So 2 multiplied by minus 2 will give me minus 4, minus 1 by 4 will give me minus 4, and this will give me minus 4 minus minus 4 will give me 0. Wow. Alright, now this is a special case where the determinant is equal to 0. Whenever our determinant is equal to 0, right, we say that the matrix A is a singular matrix. Right? Now I want you to remember this word, singular matrix. You will see this in either your multiple choice or even your the paper 2. So a singular matrix is a matrix whose determinant is 0. Alright, I was trying to prove a point here, but I got 0 one time. Alright, so I'm going to give you another example. Let's say I have a matrix B, and it is minus 1, 2, minus 2, 8. And I come and I ask you to find the determinant. Right? So the determinant B is equal to, I have to take this term and multiply by this term. So it's minus 1 multiplied by 8 minus this term by this term, which is 2 by minus 2. And this will give me minus 8 minus, and 2 by minus 2 will give me minus 4. So minus 4. Therefore, minus 8 minus minus 4 is the same as saying minus 8 plus 4. So this will be minus 4. Right? So that is how we find determinant of a 2 by 2 matrix. And I said before that a singular matrix is a matrix whose determinant is equal to 0. So let me give you, let's say we have a matrix M, and I tell you that the matrix is, let's say 2, 1, 4, and this is P. And they come and they ask you, find P such that the determinant is equal to 0, or such that M is a singular matrix. Right? This is typically how you will be asked a question concerning singular matrices. Right? They will tell you find some value such that the matrix is singular, or they come and they tell you that the determinant is equal to 0. So we know that the determinant M is equal to 0, but we know to find determinant we say this term by this term. So 2 multiplied by P will give me 2P minus this term by this term. 1 multiplied by 4 is 4, and I'm going to put that equal to 0. So 2P is equal to 4, therefore P is equal to 4 over 2, therefore P is equal to 2. Typical examination question here. Right? There's another one they can ask you. Let me show you. Let's say I have the vector, the matrix B, and I have let's say P squared, and I have I'll give you one here. Let's say 8, 2, 1. Right? And find the values of P if B is singular. Right? Now, if we know once we see the word singular matrix, we know the determinant is equal to 0. So we start off by saying the determinant is equal to 0. So therefore we set up our equation to find determinant. So this term by this term, so it's P squared by 1, which will give me P squared, minus, in brackets, 8 multiplied by 2 is equal to 0. So P squared minus 16 is equal to 0. So P squared is equal to 16. Therefore P is equal to the square root of 16. And therefore P is equal to 4. Now here's the thing. Whenever you find the square root of a number, the answer is actually plus or minus 4. So therefore P could either be equal to 4, or it could be equal to minus 4. That's why the question asks for the values of P. So keep that in mind when you do a question regarding singular matrices. Whenever you have a square root inside there, the square root of a number is always plus or minus something. Right? In this case, the square root of 16 is plus or minus 4. Therefore, P could either be 4 or it could be minus 4. It will still satisfy the equation. Right? For those of you who are not sure what I'm talking about, if I take 4 and I square it, plus 4 and I square it, I get 16. If I have minus 4 and I square it, I still get 16. Right? So whenever you find the square root of a number, the solution is always plus or minus something. Now, let's find the inverse of a matrix. Now, let me give you a general formula then. So if we have a matrix M, and the matrix is A, B, C, D, we know that the determinant M is equal to A, D minus B, C, right? I showed you this already. Now, this is already inverse. So the inverse of a matrix is written as M minus 1, M to the power minus 1, right? And that is equal to 1 over the determinant, right, which we can work out, multiplied by, here's what you have to do. You see these terms, the A and the D, we have to swap them. As in, we put D here and we put A here, and the B, we just put a minus sign in front of the B and we put a minus sign in front of the C, right? And this is all that you need to remember to find the inverse of a matrix, right? Most students, they try to learn off a formula and they have trouble. What you need to do is watch what I'm doing here. All I'm saying, the inverse of a matrix is given by 1 over the determinant multiplying by this here, which is what we call the adjoint matrix, ADJOINT matrix, right? Or we just made some changes to the original matrix they would have given us. So we swap the positions of D and A, and we put a minus sign in front of B and a minus sign in front of C. So let me give you a quick example here. So let's say M, the matrix M, is given by 1, 2, 4, 5. Right? First thing we need to do is to find the determinant. So the determinant M is AD minus BC. So it's this term by this term. So it's 1 by 5 minus 2 by 4, which is equal to 5 minus 4 2s are 8. So 5 minus 8 is minus 3. Right, so that's the first step. We find the determinant. Next step, we're going to write M inverse is equal to 1 over the determinant. So 1 over minus 3. So I can just put the minus sign here. And then I need to write the adjoint matrix. All I need to do is swap the positions of A and D. So this will be 5, and this will be 1, and this will be minus 2, and this will be minus 4. And that's it. That's the inverse of the matrix. Some people get confused. They want to remove the minus 1/3, but that's it. If you give your answer as that, that is correct. You do not need to simplify unless they ask you to do that. If you want to simplify this matrix, right, the answer will be, this is a scalar product here. So you're going to have to take minus 1/3 and multiply it by every single term here. So this will be minus 5 over 3. This will be 2 over 3. This will be 4 over 3. And this will be minus 1/3. And that is the inverse matrix. So you can leave your answer as this, still get your full marks, or you can write it like this, right? Do not attempt to simplify if you are not sure what you're doing, right? Let me do another example. So finding the inverse of a matrix is very important because we use it to solve a simultaneous equation. So let's say we have this 3, 2, 1, minus 2. And I ask you to find the inverse, right? First thing we do, we find the determinant. So the determinant of the matrix is AD minus BC. So it's this term by this term, 3 multiplied by 2, minus this by this. Okay, so it's 3 by 2 minus 1 multiplied by minus 2, and this will give me 6 minus, and 1 by minus 2 is minus 2, so this will give me 8, right? 6 minus minus 2 is the same as saying 6 plus 2, which is 8. So your next step is to write A inverse is equal to 1 over the determinant, which is simply 1 over 8 by the adjoint matrix. So we swap the positions of A and D. So this is, the 2 will come here and the 3 will come here. Put a minus sign in front of the 1. If you put a minus sign in front of the minus 2, it will become 2, right? And again, you can leave your answer as this, or if you feel you could do it, it will be 2 over 8 minus 1 over 8, 2 over 8, 3 over 8, right? And you can further simplify that as a quarter minus 1/8, 1/4, and 3/8. Right, and this is how you find the inverse of a matrix. A lot of people, when they see the inverse of a matrix, they get confused. They feel like they can't do it, but it's very, very simple. What you have to do is step by step write down the solution. You find the inverse first, you find the determinant first, and then you put 1 over the determinant and multiply it by the adjoint matrix. Right? It's pretty straightforward. Now I want to show you something else. We have something called the identity matrix. Now the identity matrix is a special matrix. So we say I, the identity matrix, is 1, 0, 0, 1. Now why is this matrix special? Let's say I have a matrix here which is 1, 2, 2, 4, right? And I take, one second, I take A and I multiply by the matrix I, right? What's going to happen? So we write our matrix 1, 2, 2, 4, and I'm going to put 1, 0, 0, 1, right? What is going to happen? So we did matrix multiplication already, so I'm going to speed through this a little bit. So it's my first row multiplied by my first column, so it'll be 1 multiplied by 1 minus 2 by 0, right? And that'll give me 1 minus 0, which is 1. So our first term is 1. And I'm going to take my first row and multiply by our second column. So this will be 1 by 0 minus 1 by 0, 2 by 1. Yeah. So that will give me 0 minus, hold on, something's wrong here. 1, 2, so 1 by 1 will give me 1, 2 by 0. Okay, I made a major boo-boo here. This is supposed to be plus, plus, plus. Wow. Okay, so you see how easy it is to make a mistake sometimes. So this will be 0 plus 2, which will give me 2. Then we're going to take our second row, multiply by our first column. So this will be 2 by 1 plus 4 by 0, which is 2 plus 0, which will give me 2. So this term here is 2 and this term is 2. And then we're going to take our second row, multiply by our second column here, which will be 2 by 0 plus 4 by 1, which will be 0 plus 4, which will give me 4. So if you look at this, you realize that if you take a matrix and you multiply by the identity, we end up with the same matrix, right? This is a special rule, or in most of the past paper questions, they ask you to show that AI is equal to A, which is to simply multiply the matrix by the identity matrix, and you're going to end up with the same matrix. So this is an actual exam type question. They might ask you to show that AI is equal to A, right? Typical exam question. All you do, you multiply it and you show that they are equal, right? This rule is very important when we solve simultaneous equations using the matrix method. All right. So as you would realize, matrix, they're very easy. It just requires some practice. Okay.